I will be talking about is applicable to different package managers as packages and package managers as well. And according to the title, it is surviving in dependency hell. I am not going to talk about how to create dependency heaven. We'll be learning on how to be Lucifer in the hell. So that being said, let's see matrix of hell. So this is a very nice image that I found where it talks about the developers and the hustle between the developers and different libraries, packages, OS, and modules, right? So one thing or the other in this aspect keeps messing up, and which eventually creates delays in release pipeline releases and stuff like that. So from here, let's see what is dependency. Let's keep that matrix of hell in mind and let's see what is dependency. So dependency is about when we depend while writing code, we depend on someone else's modules or piece of code to run in our ecosystem. And there are two types of dependencies. One is direct, and the another one is transitive. So the direct dependency is something which we directly consume, and the transitive dependency is the dependency that the dependency we are consuming is consuming. So there are multiple levels of this. Hence, it is called transitive dependency. The dependency that is on level third is also impacting the top layer of the dependency tree. So if you see this image, in this image, there are different comparisons. There's Maven, NPM, Nugget, packages, PyPy, and Ruby gems. I'm comparing these few modules, these few package managers, and if you can see, there's NPM package which has grown drastically. And these are like top 100 projects which and this graph is showing the top 100 projects that are there on npm, and the transitive dependency is just 4 level deep, and you can see the crowd that is there. All the nodes and cluster tell you, okay, this is the dependency. And every slide might contain links at the bottom, which you can use at later stage in order to learn more about it. So if you see, this is one of the readable stream. If you can see the bottom, it's a readable stream package which has 144 nodes in just 4 level of dependencies. So it is dependent on around 144 packages. It might not be direct, but it might be transitive as well. So let's talk about what exactly is dependency hell. Yeah. Uh, when we talk about dependencies and when we talk about projects, right? Currently, there are around 20% of the code that developers write, and around 80% of the code that is being consumed from dependencies or third parties. So what happens is there are multiple things. This whole situation is a mess when we have to manage it, and dependencies add a additional factor. And it adds one more variable for us to manage as a security professional or even as a developer. It helps developers, it helps everyone in creating the product, but when it's come to management, it also creates a problem there. So this is what we are going to talk about in dependency hell. So let's talk some strategies. So this is a very cool concept, that 9 circles of dependency hell, and there are different problems that people have faced with package management, uh, and they are listed down, like, are my dependencies even correct? Updating a new package and breaking something else. We have all been there. Bloated bundles. Too many dependencies are there, and you don't even know which is being used, which is dead code. Multiple package managers is another. This is a very gray area. This is a problem as well, and also it is uh, being actively used. But from the management perspective, it creates a problem. Then we'll see, okay, the package or the version you need is in the package manager. So what do we use? How do we go about dealing with it? Then we'll see monkey patching a dependency. How many of you are aware of monkey patching? Can I see a raise of hands? All right, nice. So we'll see some monkey patching there. Now, releasing breaking changes when we are talking about minor releases, and we'll talk about circular dependencies and also diamond dependency problem that is there. So the first one, are my dependencies even correct? So what do we mean by that is the dependencies that we are using in our product or project, are they even documented? Are they in the manifest, or let's say package.json file? If we talk about the npm environment, is it in the package.json file? Is it documented? Is it noted with the exact version that is being used? And the licenses that are being restrictive. So we generally take some packages that we are not allowed to use. So this happens mostly when we install the npm package from Git and do not read the license. So license restrict developers to use their product in certain way. So we should be aware of that as well. So in order to survive this, we have to set up a proper vetting process. And dependency manifest should be single source of truth. Uh, uh, in your organizations, how many of you do a proper dependency vetting before utilizing that in your own projects? Can I see a raise of hands? One? Oh, nice. I was expecting zero, but yeah, that's a very important thing. It obviously creates a time delay when developers use the dependency, because it goes through one round of gateway and audit. But yeah, vetting process is very much important on understanding the validity and understanding if this dependency is really important in our or really needed in our environment. And yeah, keep everything in single source that is package JSON, which sometimes it happens that the developers install dependencies and not mention in the package JSON. So at the build time it works, but when it goes to the server and the package JSON gets, it pulls the packages and that is not being called. So it again creates a mess in itself. So let's talk a bit on the vetting process. So one should vet the dependencies before using. There are multiple factors that needs to be taken care of to understand if the dependency is really legit and we really want to use it. So we can look at multiple things. Who is the author of it? Who is the maintainer? How many issues are there? What kind of discussions are going on these issues? Uh, how is the popularity of the? So popularity can be faked, but popularity gives us a sense. Okay, this is being used by different organizations, so that also helps in the vetting process. Then set up a process to identify a drift on what is being used in the product and what is not documented. So there's this project called Vet, which helps you in vetting different dependencies on all these factors, and it also looks at the popularity of the things. So if time permits, we'll have a demo of it as well. The next is updating a new package and breaking something else. How many of us have done that? We have just npm update and we broke the project entirely. So that's a very common thing that we do. But again, we hear no dependency vetting. We don't know what the dependency is bringing. We have not read the change logs on what it is bringing. Is it a major release? Is it a minor release? And even the authors that are for dependencies, They sometimes do not put in enough effort in doing a proper semantic versioning, and you can't even trust these authors. I mean, it's a in a human world we should live on trust, but in a security world we should always be skeptical. Okay, something might come, uh, so we cannot really trust the third-party authors as well. So yeah, can't emphasize enough. We should have a proper vetting process, and to deal with the trust issues that we have with the third-party authors, if you are big enough to maintain, keep a cached copy of the dependencies that you are using. But if that is not what you can do, do a proper due diligence, do a proper tagging on the commit that you want to use on whatever source code of the dependency you read. So do a proper due diligence before using the dependency, and yeah, it is also accepted risk that something might happen. That's always there. So bloated bundle, too many dependencies. So uh, that multiple things that happens. One is slow build. The build time takes forever to create a production ready environment, and there are some older or unused dependencies, dead code that is present. So to do this, again, inventory and audit the dependencies. Uh, how many of you have seen like in a npm like in a project, how many dependencies are there? So this is a I just cloned a cms. So mm, in this is a very minimal cms. So if we see how many dependencies are there, oops, sorry about that. Yeah, npm list. So the direct dependencies that are there are only these many: 1, 2, 3, 4, 5, 6, and 7. There are 7 dependencies. Now, if we try to see, okay, how many of how many of them are transitive, because these are direct. Now, if we go to see, let's say depth to, let's say 10. Uh, sorry. Sorry, yeah, 100. Let's go the highest number we can think of because I have tested it. So 100 is the maximum transitive level it goes. So 100. And if we first, let's see a matrix kind of thing. We have a huge list of dependencies that are transitive. Some of them are unmet optional dependencies. These are not even considered. And now if we try to count, there are, if you can see, there are 897 dependencies in that minimal project that we saw. So yeah, too many dependencies. The npm binary, the npm binary helps in taking care, listing, and inventorying them, and then we have to audit. So inventorying does not mean we should know what is there in our environment. So if something breaks or something happens, we have enough information to deal with it. Now, multiple package managers, again, as I said, this is a gray area where we talk about slow builds and package conflicts. So the ideal scenario is use one package manager per language. If you're using, let's say, Python, try to stick with PyPy or Conda. Do not use both because both of them are different companies trying to maintain their own packages. If you're using Node, then npm and yarn are mostly compatible with each other. So do your own due diligence to see, okay, if the different package managers are compatible. But in an ideal world, it's better to use one package manager. Now, there might be a problem that the package that you are looking for is not available in that package manager. So Use Git repositories to install packages and maintain them yourself, uh, instead of adding more package managers to see, okay, what is the problem and what is not. Yeah. Then let's talk about monkey patching. So monkey patching is something, okay, I have a problem with this dependency and I am not able to solve it with any, I tried contacting the author, they are not doing anything because open source world, not everyone is getting paid to do what they are doing, they have different things. So the author is not doing, not catering to the request that I have made for the dependency. So what monkey patching is, we create a code that changes the behavior of the dependency on runtime. So if, by the definition, a technique used to dynamically update the behavior of a piece of code at runtime without altering the original source code. So that's the monkey patching. Now there are again problems with monkey patching. It's difficult to upgrade the softwares because let's say developer A has done some monkey patches and has if some other developer tries to see, okay, what are the patches that are being made, it would be very difficult for them to understand what are the patches, and then there are always a chance that there can be malicious monkey patches and you won't even notice because of the huge code base. So again, in an ideal world, you should not monkey patch, but we don't live in an ideal world, and we do monkey patches and do try to improve the dependencies that can cater to our project. So then we must store and document these properly at a separate folder where there are monkey patches and link it like that. Next, breaking changes in minor and patch versions. So ideally, the minor version, there are three in a syntactically, there are three parts. When you see the version, like let's say there is a package called request version 1.0.0. There are three parts. So all the three parts have some meaning to it. The last part is about patch, which is the small change that is being made, which do not really impact the product, or but does some minor bug fixes or something. Then there is a minor patch where uh, there are some things included, but new features included, but there is a backward compatibility. And then the third one is the major, which tells, okay, this is the problem. This may have breaking changes, not may, this will have breaking changes, and please update or upgrade accordingly. So here the non-semantic versioning is a problem. If you can see, that was a Python project, that is HTML5 lib, which once had the version number as 0.999 and so on. So the same thing that we talked about, major, minor, and patch. We have to do proper versioning, semantic versioning. And this is another request project where we have the proper semantic versioning so that we know, okay, if something is going to break, we should be aware of that. Then circular dependencies. So I'll give you a funny example. In npm, there's a package that tells, okay, is it odd or not, which is good. Then there's another package which says if it is even, and what it does is it calls the isodd function, isodd package, and if that output is not true, then it tells it's even. So both the packages are using the same, like, again and again. So if you can see, the package A using package B, and B is using package A, and it might have unintended consequences. Something or the other often breaks in such scenarios. So how do we go about dealing with it is identify and avoid circular dependencies, but if we cannot, you mainly use different design patterns while you're working on the project. and which is the more architect way of looking at the project. And yeah, so mostly we have to avoid dealing with the circular dependencies. And to understand what are the circular dependencies, there's a npm project called marge, madge, which helps you in identifying if the project has some circular dependencies or not. Again, the diamond dependency problem. How many of you are aware of the diamond dependency problem? Okay, so have you seen something? Okay, there are multiple packages are being called. Package A, package B, and package C. Package A is using package D version 1.2, and package B is using D version 2.1. And both of them needs to be there in the project in order for them to work. So different version of the same package in the same project. So we have to perform deduplication of the dependencies that are there. So in the node environment, we can do that very easily. So npm provides a dedupe command, which tells, okay, these are the dependencies that are present, and this is the maximum you can raise up to, so that both the dependency A and dependency B will work perfectly fine. So we run dedupe here. It goes through the entire dependency list, and it tells you, okay, these are the duplicates. So if you see here, and let's make it 5 so it's easy to. So if you can see in the list, these are the deduped packages. So now when we do npm update, it will update the packages, and it will bring it to the minimum version that all the packages will work together in synchrony. So all of this, we have talked about the strategies that we are going to implement. We are going to talk about, we talked about what was dependency hell. Now we'll come to the conclusion and talk about security and product teams, how they love each other, and how they should love each other and work in, like, they should complement each other, because none of them are there, because both of them are there to create the product and not the otherwise. So the security and product team should complement each other. The security team, we oftentimes it happens, we have a list of vulnerabilities that we saw, and we send them to the product team. Okay, these are like 1,000 vulnerabilities in this package, or please fix it. But from our security engineering perspective, we should perform our due diligence, validate if the vulnerability is really impacting the product. We can use different methods like reachability analysis, perform source code review if it is really see the data flow, how the data is flowing, to understand if it is really impacting the product, and accordingly give the severity, so that product team understands, okay, it is coming from a place where they know this is critical, so we have to fix it. Otherwise, if you give them 1,000 vulnerabilities, there will be a fatigue in developers, and none of the issues are going to be fixed. Yeah. So understand the problem, and then understand the impact, and then suggest. So closing points: minimize the dependencies as much as you can. Standardize the package manager that you are going to use. If possible, try to keep it to one. Follow semantic versioning whenever doing. This is for the npm author, the package authors. Follow semantic versioning, and vet the dependency properly before using it. Check for associated security issues that are there. Check for CVs. Check for exploits if they're there. Then check for backward compatibility. How much backward compatible, and is it backward compatible enough to work with your product? Then you ain't gonna need it principle. This principle is very fun. So I'll tell you a news that happened. There was a left pad named dependency, which was there, and the author of that dependency took the package down and it broke the internet literally. It broke packages at all the major companies. It broke React. It broke major products that were there, and this happened because of depending on the author that has created the package. And the funny part is the package, left pad package, is just 11 lines of code that people were using. So if you are not going to need, if you can just write that 11 lines of code in your own system and make a module. So if you're not going to need it, just don't include it in your project. Then license and legal considerations. We talked about this on how important is it to understand what is the legal complications when using a package. And duplicated functionality. So if there is a product, if there is a package already present in your system that does the same thing that the new package you are trying to import is doing, just don't use the same functionality. Then look at the popularity, obviously, to understand how much, what's the, if it is even safe enough to use in the environment. Not only popularity, we talked about multiple other things as well. Then check for unused or too complicated dependencies that are there. Try to avoid them. If something happens there, it will impact your, it will make your life miserable when you're doing the incident response. So yes, this is me, Kumar Ashwin, and thank you. Embrace the chaos.